We will solve this today's LeetCode problem. This is LeetCode hard. Let's see what it is. So this is maximum scored words found by letters. So here we have given a list of words, list of single letters, might be repeating, and a score of every character. Okay. Return the maximum score of any valid set of words formed by using the given letters cannot be used more times. Okay. Words I cannot be used more two or more times. It is not necessary to use all characters in letters, and each letter can only be used once. Okay, okay. So we have a given a list of words. This is what a list of words here, right? And list of single letters also be given, and which can also be repetitive. Okay, so this is the letters which we have given here. Okay, and we have given. We need to find the maximum score of any valid set from these words formed by using the given letter found by okay, and words I cannot be used two or more times. Okay, so uh, if you if we analyze this question, what is he is trying to tell that we need to uh, take any sets of valid set of words from this. What are the valid set of words? The valid set of words means here the words which can be formed by these letters only. The words which can be formed by these letters only, right? This need to be understand that the valid set of words means the words which is formed only by these letters. So if so and we need to find the maximum score by choosing any valid set. So how we will find that? And so we have given a score of this. So what is this score represent? This represent that A score is 1, B score is 0, A to Z value. This is given A to Z score, A to Z alphabet score, A to Z score, right? A B C D like this, right? A B C D E F G H I J, right? Like this, right? This is given to up to Z, up to YZ, right? XYZ, right? This is up to XYZ. This is given, right? So, and what is telling that we cannot use words like cannot be used two or more times. It means we only can take dog once time, dad one time, good one time, cat one time, right? So this question, if you observe, if because this question, if you have if you are solving, if you are solving the last 3 4 days lead code problems, lead code POTD, lead code to problem of the day, you are definitely know what this means. This is a this is again subsets. This is talking about subsets, that we need to form each and every subsets. So if we see constants here, we have given words length 14 only. So 2 to the power 14 is applicable here, which is something like 10 to the power 4. And for each letters, there can be maximum of 15 length. So that will be only 15. So and something also extra, so that will be achievable. Yeah. So I think yeah, subsets will be a good options from here. If you are solving last 4 days lead code problems, you will already know that this is again a subset problem. This is again a subset problem. This is again a subset problem, or you can use it by recursion plus backtracking. We will see how that is. If this is yesterday's problem, this is yesterday's problem, right? So this is recursion plus backtracking, right? So how is this is how I analyze this recursion backtracking, because it is saying that we need to find the maximum score by choosing any valid set of words, by choosing any of them, and no words are repeating. It means I need to form each and every subset which can be possible in this words, right? In this words. So what are the possible subsets which we can form? We can take dog, or I can take only cat, or I can take only uh, that, or I can take only good, right? Or dog, cat, or dad, dog, dad, right? This is how you form subsets, right? But here you see here one thing, that the word is should be valid, and what the word should valid means the words which can be found by these letters only, and here are the letters. So if you see dog, D-O-G is present, so this is okay, this is okay, right? If you see cat, C A, but T is not available here. T is not in this letter, so this is not okay. This is not a valid set of. This is not a valid set of word, right? This is not okay. If you see that D, A, and D again, if D is present two times, there should be the same number of frequencies present in letters, right? So D, A, D is present. It means it is okay, right? If you see good, G double O D is present. This is okay. Now, if you see here dog and cat, so DOG is present, CA is also present, but T is not present. So this all subsets is not valid. So this is not valid. Now, if you see here, D is present two times. Sorry, D is present three times. So D should be present three times. One, two, three. Yeah, D is present. Good. O is present one time. O is present two times. It is good. G is present one time. G is present here. A is present one times. A is greater than one. So this is valid subset. So we need to find all the frequencies. We need to find the characters for each subset in every word and match the frequency with the letters present here. If that is okay, then the subsets is also okay, otherwise it is not okay, and we need to check for each and every element. So we understand that we understand that I can form only that subset whose only that's I can form only that subset which has words included. I can form which has word included. Okay, sorry. That I can form only the subsets which has a words, which has a frequency of words, which has the words. uh, I'm not able to make a statement, but you understand, I think. If you see here dog and that, so I need to calculate all the frequencies of alphabets which is present in all over the words in particular subset, right? So you need to uh, find the frequency. We need to check the frequencies frequencies of all characters in each and every word present in a subset, right? Subset, and that should be, and the frequency of characters should be, should not be greater than the frequency of characters present in letters, right? Right. So this is the two statement. This is the one statement which I am claiming, right? Understood. So this is the one thing which I we need to observe here, that we need to check all the frequencies which we want to include in our subset, and each frequency's character should not be greater than frequency present of character in this letter. Then only we can claim that this subset is valid. Right? So the one thing is clear. The first thing is clear. Let's write here that I need to store the frequency of characters present in present in the letters, right? And we need only one subset. We don't need all the subsets. We need only one subset which gives you maximum score, right? We need only one subset. So I need to store the frequency of character present in letters, right? This need to be stored, okay? And also what we need to store, we need to also store the frequency of characters of each and every, for all the words which we want to include in our subset, right? And this both should be checked. This is the first two things. Now, if you know how to make subsets, right? If you know how to make subsets, you are definitely good to go, right? So if you have solved the last two three problems, you should try this. You should first try this, then comes to here. You should first try this. If you solved at last two three problems, last two three days problems, right? So you should definitely try this first. After this, right? So okay, now the next thing is how we will know, how we will implement this simply, right? So let's say, uh, yeah, let's say this example, this 20 xxz ax bx. So suppose this is dog and cat is given, dog cat that good is given, right? So let's take the dog, cat, and uh, dad, and this is good, right? This is given, this is given to us, right? So if you try to make its recursion tree, because I need to choose now. Here I need to choose. If you find it by recursion, we have options. We have options that either I choose dog or cat or dad or good, or either dog, not cat, dad, then good. Right? We have option to choose each and every character from the list of words, right? And check the also check after and also check the validity, the valid that the words which we have taken is valid or not. And how we will check the validity? The same thing. We will match the frequency of characters of all the letters, right? This is the validation. This is the validation. This is the validation. This both are validation, right? This is how we will check. So if we have option of choosing and not choosing, then we will see the recursion tree. Let's try to initialize this, right? So this is here dog, right? How we will check? We need to maintain word here, right? uh, Letter here, so the frequency of letters. Let's represent frequency of letters with f, right? This represents frequency of letters. And also I need to maintain a frequency for the words we will choose, right? That's let's represent towards uh, a frequency is count, right? Let's represent with count, frequency of characters of words which we have chosen for making subsets, right? Now this f and this cnt, and also this cnt to be taken, right? So this is the this word is a singular word, this dog, right? This is the dog, this is a singular word, right? This is taken as word I. This is a word, singular word. This is the frequency f, and this is the count, right? Now what we need to see, we will see here that the first thing, either I can choose a dog or not. If I don't choose it, I will not include in my subsets, right? So okay, one thing is also clear that uh, for representation purpose, I am taking it as a 0, 1 and 2, right? I am taking as a 0, then 1, and then 2, and then 3, right? This is we are taking. So I am taking that I will include this 0, right? I will either include or disclude it. So if I okay, I need to also make a index here. So let's represent index. Let's take an index 0. Okay. So if I want to include or disclude it, so the first thing is, if I not include it, it will give me 1. This is not included. This frequency, this frequency of letters. Okay. First need to think, I need to calculate the frequency of letters, which is AACDDGCO, right? This is the count. So what are the frequency we need to store here? So for that, I need to store A as 2 times, C as 1 time, D as 3 times, and G as one time, O has two times, right? O as two times, right? This is how this is the frequency. This is the F. This is the F, right? Now for the CNT, this is for the CNT. What need to store? Okay, for the CNT, I have not taken the first word, which is a dog. Let's write this here. Let write this here, right? I have not taken this word, right? So for dog, I have not taken here, and this F and CNT is the same which was is before. But after choosing that, I mean I want to choose it. I want dog to be chosen in my subset. So index would be iterated, but dog is chosen. So I will store this zero in my subset. It means dog is here. This means dogs is here, right? F, what should be F? This is A2, C1, D3, G01 and 02, right? And this count should be include this dog character. So I will just include my character here. D1, O as 1, G as 1. Okay, right? After this inclusion, this F and this CNT will here now, 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 now. When I have included this and I also include this my CNT. Now I will check further for next index. Either that is for one, right? I will choose for one. I will choose for one. So when I choose for one, when I try to choose for one, let's make this something here. Yeah. When I try to choose for one, what it will give me? Either I can include or not. The same thing. So this will become two. I don't choose want to choose the first. So F will be same, CNT will be same, right? Okay. Now when I choose it, so this will become same. This include 0 and 1 both. This become F, and now this count would be included here. So the oneth is cat. If I see cat, C should be 1, A should be 1, T should be 1, right? I'm not checking if this is valid or not. I'm just inserting it. I'm not checking that it is a valid or not. I'm just inserting it. We will check it when we complete it. When we complete this subset, because if you saw that video, the subset video, you see that we got a subset only when we move to its leaf part. We only get subset at a leaf part always, right? We only get a subset at a leaf part. So this CNT would be included, right? Now for this, we have another two options. This two, this three. Either I include this three or disclude it. So if I include it, if I don't include it, this becomes zero again. This becomes F and this becomes CNT. This is a updated CNT for this only. This is for this only. Let's write. I'm not able to write this CNT at here and represent this CNT at here. Uh, how will I claim? Okay, let's make this as a CNT CNT 0, which represents D1 O1, because it will it will make you easy. This CNT 0 is at here. This CNT 0 it has here, right? This is CNT 0 at here, right? After inclusion of 0, right? When you include 2, the CNT the CNT 2 is here, right? The CNT 2 is here. When we don't include, the CNT 0 will remain same. This CNT 0 will remain same. So let make it as a 0. Let make it as a 2. This will become 0, right? Okay, now when we want to don't include, the CNT 0 will be same. But when we want to include this third part, when we want to include it, it becomes 3, 0 and 2. This dat is included. Now this frequency and the now CNT will change. When we want to include 0 2, I need to calculate zeros and 2 frequencies of characters. So CNT 0 is before. Now and to include the CNT 0, what will be? This will be CNT 1. So dog and dad same. I mean this dad and dog is characters are should be calculated. So D is included three times. So this should be three. Oh, this should be three. And sorry for that. So C O is included one time. G included one time. I didn't mean that before, right? So uh, O G is one. A is A is one, and yeah, these four characters are there. Four distinct characters: D O G D A D. Right? D O G and D A D. So these are the characters we need to store. We have stored here. So this is for C and T one, right? So now, now for this, these characters are there again. For this again, I have two options. So if you see here, what I'm doing, I'm just going at least, but till now go to only third index. So I will just try to include third or not. So this is fourth, this is third. Now I have included or not included. I have not included. This F will be same. CNT zero will be the same, right? Now when I try to include it, this become four. This become three, three or something else. Why I have written three here? No, this should not be three. This should be four. This should be zero. This is F and this is CNT zero. So this is four. Now this zero. Now this three should be included because I have not excluded once time and second time I will include it. So if I include it, it becomes three. Now this frequency is same. Now count. The count will be changed because zero three is included. So CNT zero here. If I include CNT zero with my this count, which is good, and this is dog, right? So CNT three will be formed. CNT three will be formed, which is good and dog. So D is present two times, O is present three times, G is present two times, right? So 2, 3, 4, 4, 5, 6, 7, 4, 5, 6, 7, right? So CNT three will be formed. Now, when you see 4 is at last, this is the last index. It means I definitely got some subsets which can be a possible answer for me, right? I'm not making all the trees for here because that will be a very that will take very lot of time. I'm just making try to understand that how this works. If you want to see a whole recursion tree, you can watch last video that I have make all the trees recursion tree and shows you how it works, right? This is here only for see make you understand that how this recursion works, right? So this is 0 FNCNT 0 and this is 03 FCNT 3. So this CNT 0 will return something. Now before returning, I will check after this that whether this CNT 0 characters, these characters frequencies of each characters is less than equals to the letters present in my frequencies. Why I'm checking that? Because that will be only the valid subset, valid words present in my subset, right? So I will check for CNT 0. D is present 1, D is 3, good. O is 1, O is 2, good. This should be O. G is 1, G is 1, okay. This is a valid subset. This 0 is a valid subset. So how much score it will give us? This 0 represent dog, right? So DOG means the letters which we have here. Where is it is gone? Here. Yeah, this is score. This is score. This is score. This is score. Uh, yeah, score. Yeah, yeah. This is score. This score should be checked. This represents A B C D, A B C D E F till Z X Y Z X Y Z. A dog is D. D is 5, right? So 5 plus O. What is O here? Uh, F G. Okay, I will see from here. O is 2, right? O is 2 here, and G is again 3, right? Again 3. So this becomes 5 plus 2, 7, 3, 10, right? This will return 10 because this is a valid count frequency. This will return 10 to his parent. So it returns 10 here. It represents 10 here. It returns 10 here. Okay. Now the main thing, the CNT 0 which we have here with we so one thing, in this part, when we don't choose it, we have inserted something in my frequency. No, we haven't frequency, so we don't need to take attention that we need to backtrack this, right? But in this part, when we chosen to be inserted this 3, right? So 03 cnt3, this cnt3 should be checked. Let's check. D is equals to 2, D is equals to 3, valid. O is equals to 3, O is equals to 2. It means this dog and good is not valid a subset, because O's frequencies, O frequency is greater than the letters which we have given. So this is not a valid subset, which we can't take. This is not okay. This is not okay. We don't return anything. We just return. This is not valid. We don't move it from there. We just return 0 here. From here, we just return 0. So this returns 0. So we have 10 plus 0, because that's right part would not give me anything, right? Okay. Now the next thing, this represent 10, and this part, this is still left to be sorted out. So if I see here 02, so I need to include 3, or I have two options, either I include 3 or not. So if I include 3, this good character should be included in my cnt1, this cnt1, right? So uh, so this is the same thing which we are doing. So if we want to include it, I will just insert this here, and count 1 will be represented in my characters. So one thing I need to just tell, that suppose this would be okay, suppose this is would be okay, suppose this is the frequency of count characters is is within this letters given, right? So when you backtrack this, when we are returning this count, if you included some words characters in my frequency, you need to delete it also. Why I'm saying that? Because this cnt0, this cnt0 should be at the original form. You have manipulated and write it here cnt3, but when you return it to its parent, this parent should be cnt0, not cnt3, right? So you need to backtrack from this. So you need to delete some of the you need to delete which you have inserted from the last character. So this is the backtracking, which we have already told you in my last video very clearly, right? So you can watch that, right? Simply. So this is how we done this. So what we are doing, we were we are we are just maintaining the frequencies frequencies of all the characters which we want to choose in our subset. And after all the process, we check we check that the words which all the characters of words in the subset should be check that frequency of all the characters in the subset should be within the limits of the frequencies of all the characters present in the letters present in the given letters, right? This need to be checked and found. So we have two options: we include, exclude, right? We do like this. We just include, do like this, right? There is one method only where there is there is extra method which we discuss if the time permits. But this is how we do by recursion plus backtracking. This is also the same problem, right? The subset type of problem. So let's see the implementation part. You will be better understand. So I need to implement it carefully, right? So suppose let's take a words dot size words dot size. The first thing is clear, right? The second thing, I need to store the frequency letters. So I need to take a frequency which will be 26 characters, right? Which can be 26 characters. So for auto C, for auto C, these letters should be included in my frequencies. So this frequency C minus A. So C minus A represents 0. C minus B represents 1. That's why I have taken 26, right? So this should be incremented. Now I need to maintain. I need to form. I need to find the maximum score from any of the possible subsets, right? From any of the possible subsets, I need to find a maximum score, right? So I have calculated frequencies of the letters which we have given. Now I will start a recursion. The first thing is index. Second thing, the words. Third thing, this frequency. Fourth thing is the characters which we are taking. This CNT, the CNT part. So I need to maintain a CNT which we need to take account 26 0, right? I will just pass this all things. Now let's start the word. This is solve, right? This is the index, this is the string which need to be passed by reference. You know already if you watch videos why I'm passing it by reference, because it will not, if I pass a value it will not create copies, right? If we pass by value it will create copies. That's why I'm representing by reference, passing by reference. Third thing, I need to pass frequency of letters, and the last thing I need to pass the count which will be updated again and again, right? The what we are doing, we have two options. We have two options for each and every characters. So I will choose. So first thing, I will not take I will not take the current word. If I don't take, I don't need to do anything. I will just increment the counter index and move on. But if I want to take, if I want to take, if I want to take, what I need to do? I need to update this count. I need to update this count. Okay, okay, okay. I need to update this count. Also, I want a score here. I want a score because at last, if you see, I'm returning a score from here to my parents, because ultimately I need to find a score. So I need to take a score also represent in my answer, right? So if I take only, then I can store in my answer, right? I will calculate for this. So if I want to take it, I will I will move in this characters. So this will be represent as J word I dot size J plus plus, right? So I will move in all the characters and store its frequencies in my count, this count, right? So how will I represent this? The same thing which I represent this frequency, the word I J minus A plus plus. Also, I need to include these characters in my answer, right? So I will include this answer plus this word ij should be present here, right? This word ij should be present here. Hmm, this word ij should be present here. Okay, I need to store the count also now. So I need to pass it also. This answer should be, this count also should be also passed from here. This score should be passed from here. So let's represent a max score as here, right? Or let's do this like this. Okay, answer should be here, and I am taking the max of both that represent the score, right? Let's take this. Okay, so what we are doing, we were storing the characters, and at last when I find all the subsets in my answer, I was returning its scores, right? I was returning its scores. Okay, I was returning its score. Okay, so one thing we can do is here that I will also calculate scores along with that. So what I mean, I will calculate scores along with that. So the first score is zero here, right? The first score is zero. When I include this zero, so I need to calculate a score for this. For this zero, it is dog. So the dog gives us 5 plus 2 plus 3, which is 10. So the score is 10 here till now. When I move to here, the score is still 10. When I try to take another character, that is 1, which is a cat, so will include 10 plus this cat. How much cat will give? 9 plus 1, 10, 10 plus, and t is not here. T is not here, right? So if t is not here, so I need to check whether t is exist or not. So if t is not here, so it will don't give me some anything, right? It will not give me anything. So this cat will give me 9 plus 1, which is 10 again, right? So this is becomes 20 here. Again this becomes 10 here, and this becomes 02, which is dad. Dad gives me 5 plus 10 and 11. So this 10 plus 11 is 21. And at last this is again 10, and this is include 0 and 3, which is good. Good is 4 2 to 4 plus 5 6 7, and 7 plus 5 12. 12 and 10 is 22, right? And this is 10. So if you see here, I have already stored I have already stored 10 here. I will check CNT0 is valid. It is valid. So when I backtrack this, I have not added anything in my count and CNT. So I don't need to do anything. But I have a 10. So I will just, it is a valid subset. So I will just include in my subset. Okay, one thing's here, that this is a not valid because this cat is not included. So we will not move it from here. We will not move it from here. Right? We will not move it from here. So we will not move it from here. So after this is also not valid. So this is also not okay, right? So when this is okay, we are moving only then. If it is okay, if it is okay, then we are moving in that direction. Otherwise, we are not adding any of this, right? So this is how we are going. So if this 02 is valid, then we are moving in that direction. So this has stored 10. Suppose this is okay. Suppose this is okay. So I have told you that I will backtrack this frequencies also. So I will also backtrack this count total score also, because before it was 10, but I have included 3 here now. So if this is okay, then I am telling only, right? So the backtrack first rule is, which you have included before, you just need to make the same thing before. The first thing, backtrack rule backtrack thumb rule is, uh, the anything which you have added which you have added current current which you have added, you need to remove it to make all the things the same, before same all the things same as before, right? This is the thumb rule of backtracking. So I have added total score, I have added CNT. So when I backtrack this, I need to remove which I have added and also remove the score. That's the rule of score, right? So what I'm doing, I will just uh, it's not no need to make void. This just make a void. There's no need to make a int. Just return a void, right? I will, because I'm not returning any score. I've just stored in score in my total score. So this will be the score. Let's pass it 0, because initially it is 0. So now the main thing. This answer should be here. Now this score should be calculated here, because I want to include this word. I want to include this word here. So this need to be calculated here. So the word ij means this code. Uh, okay, this code is same here, right? So let's pass it here, and let's make it as a uh, we make it as a final answer here, right? The rest here, any variable you can take, right? This can be any taken variable. So I need to pass score also. It's a just an implementation that I'm just I'm just dealing with, because it's very much complex to implement, right? So this is score, this CNT, and this rest. So this, in this rest, I need to store this is score, and what do I need to check? These characters, this character, this character. So what this represent? Word I minus j will give us, word I j minus a will give me the count, right? And this count will represent anything that 0, 1, 2, 3, and this will fetch the frequencies from here. This will fetch the score from this score added, which will give us the added, right? So this will be added in our uh, temporary scores. Now when I make this store all the counts of frequencies in my count, I need to check whether it is valid or not. So for checking validity, I just need to iterate in this from 0 to 26. So let's take it as a k. I will just iterate in this to all the characters and check this CNT k is should be not greater than this frequency k, because if it is greater than, it means this is not a valid this is not a valid subset which have all the words, because characters are greater than the letters which you have given. So it means, so it should be less than, it should be not be greater than. If it is greater than, we will make this bool flag 1 and break it. So if this is a valid, this is a valid, this to need to be checked as a valid, right? if this is if this is not, if this is a valid, let's make it as 1 and let's make it as 0. And if this is valid, just for only showing you correctly, if it is valid, then only we are moving in right direction, because I have taken this and I will move in right direction. uh, I have taken this, right? So I will just move in right direction for this. So no need, because this is a void, no need to call this int not take. Just this is also not needed. Just solve function I plus 1, pass this all things, words, frequency, count, score, and the total score, which is rest, right, which we have found till now. I will move in all that. After this validity, when all the things have confirmed, I need to backtrack this. For backtracking, I need to make the same thing as before, right? Make the same thing as before. So again, move in this word size and decrement this, which we have done in count, right? Also, I need to delete the score which we have added. So I will just do minus minus and this minus. So this is how it's get backtrack. This is how it get a backtrack, right? Now when will this recursion and this recursion will stop? When this I is greater than equals to n. What is n here? N is a size of words, a vector of strings words, right? This is words. So when I is greater than equals to n, it means I got a definitely a subset. I got a definitely a scored here, which is 22 or 10. If it is a valid, of course. If it is valid, then we got a valid subset which we want to include. So I will just include a max of answer rest here and return, right? So this is how we will solve this. I hope that I have not maintained any implementation here, because it has already taken so much time. So after this, I will just return an answer, because I want to find an score, maximum score. This is the maximum score, right? Let's run this. Try to run this. Hope I have not made any compilation error. Yeah, I made there. What is here? Okay, I haven't passed this code and the rest here. Okay, let's run this again. This should be words. There should be words. Here also, I think words, and there should be words. Run again. Score word size. Okay. Parenthesis problem. This should be solved. Okay, again here. Okay. CNTS. Compilation errors. Again. Uh, Identified arrays. Line number 38. Use of undeclared arrays. Why undeclared? I plus one frequency count is code and this is res. Something is okay. Here res. Okay. Okay. This should be zero, not res. Or you can write it like this: res zero and pass it here, right? Or you can write simply zero and remove this. You can try both of this, right? You can try both of this, and I think don't have any compulsion error. Let's run this final. Very much compulsion error, right? Yeah, it passed successfully. Let's submit it. Hope it get passed. Yeah, we have passed it finally. So this is how we will solve this. We are just doing that. We are just storing count and frequencies, and move and also score temporary score, which ultimately, and we are just going taking or not taking. And if I take, I need to include the count of frequencies characters and include in my score, and check if it is a valid. If this is a valid, then we will move in all other characters. Otherwise I will not remove it. After this recursion, either I, if this is valid, I take it or not. I need to backtrack this to maintain this count and this score. And when we get a hit at the base case, I will store the maximum answer, and that is the maximum answer. This is how we will solve the problems. And this is the time complexity will be, what will be the time complexity. So the first thing, we have options for each and every characters. Okay, so first thing is I need to store all the character letters here. So I need to move in that. So that, let's take am as count letter size, size of letters, size of letters. So O of m for iteration. Second thing, for each and every word, I have option. So that would be, so n is size of words array or vector जो भी, array of words, size of array of words. So that have the option of 2 to the power n. For each and every word, I am I am moving in all the words to store in my count and score. So that would be again O of take uh, the length of that length of words, length of word I, words I, length of word. So that will be L. And for maintaining this count, that would be a part, right? So which we have already taken. So this is the okay, sorry, this is the time complexity would be there for 2 and 12 would be there. So ultimately it is, you can you can tell it as, so this is the time complexity, right? The space complexity will be, so this space complexity will be, we are taking a frequency, we are taking count also, and we are not taking anything, right? We are taking frequency and count. So that would be 26, again 26. And there would be a recursion stack, auxiliary recursion stack space, that would be depends on this number of words. So that would be O of n, right? So this is how we will solve this problem. This is the time and the space complexity. So thank you so much. And okay, the one other methods are also here, that is the iterative way, the bit manipulation way, bit manipulation. uh, the subsets which you form, the subsets which you form, the subsets form, and the subsets form, right? This mid manipulation way, the same thing which we have told you previously. If you haven't, let's try this. Let's please watch that bit manipulation, and try to solve this by your own, right? Try to solve this by your own. After watching this, you will definitely will solve this bit manipulation by doing bit manipulation. This is all your homeworks. uh, let's comment it that who solved this after solving this, after solving this, right? Thank you so much. Bye bye. Have a nice day.